Hey, and welcome back to part 2 of this Build a Web3 app on ZKsync. In this video, we're going to be taking the AA starter application that we worked on in the previous video, and we're going to be changing it around a little bit to do something a little bit more interesting than just sending some call data and value inside of the application. So this is the same starter application. You can find the link to it down below in the GitHub. But we'll be starting off from this very same place and then building something cool on top of this. So right now I have this running on my local host. So here looks like a pretty ugly error, but this should be running on localhost 3000 here. So if I run yarn dev, I can go pop this up over here. And here it is on my localhost 3000. And if I want to actually just go ahead and log in, I can log in with a temporary email as you see here. Pop that open. All right, and we're in. So we have the same application that we had from the last time. There is one small change that I did make. I refactored a couple things between the last video and this, but just for code changes, but also I wanted to show one thing from the account. There was a question from the comments was, can you export this account? Can you take this account elsewhere with you? And you certainly can. So I created this button down here that you'll see, which if you wanted to be able to export this account, you could actually take this seed phrase and move it somewhere else. So this is something, the right to exit from this account, from this application is always right here for you. So I thought that was a really good question. I wanted to make sure to be able to show that functionality in here. So you could see this account, take it somewhere else, put it in a MetaMask wallet, put it somewhere else. You certainly can do that. Great. Okay, so what we're going to do from here is we're going to change this application a little bit. I want to make it from something that's just sending transactions, right? We have this to data and value field to doing something a little bit more fun in the Web3 space. So like the first application that really took off in this space is ERC20 tokens. So I think that's going to be the one that's going to be the easiest thing to work off of here. So that way we could just like mint some tokens here and show it within the UI, right? That might be kind of fun. So let's go ahead and mint some tokens here. So the first thing that I'm going to do is I'm just going to change a couple things on the UI just to make sure we have live reload working. So let me go ahead and do that. To show you a little bit more about how this application is set up, if you go into app here, this is going to be your routes in the Next.js application. So what we can actually go to here is the home route, which is the one that's going to be hit when we are going directly to this this dashboard here. And you can see that it has a title called Send Transactions. If you wanted to create another route, you could create another one and you could pass in a title to the dashboard to sort of change this title here. So we're going to say, let's call this Mint Tokens. And then hopefully over here, now this is changed up here. It says Mint Tokens, right? So that title is being passed through there. So you could create another dashboard here if you wanted to and create like another UI if you wanted to do that. I'm just going to go ahead and modify the one that we have here to just change this one to make it Mint Tokens, doing something kind of cool. All right, sweet. So we have this transactions main right here. This is going to come down into components. So you see this in components, dashboard, transaction. This account right here is what controls the account UI, but this transaction one is the one that controls this transactions UI. So it has a bunch of stuff in here. There's this transactions context, which we're going to take a look at in a second. This is basically making it so that when you go ahead and just send some data here from your account, to another account, it's going to create a transaction. It's going to add it to this context that's accessible anywhere within this transactions UI. So this transactions component over here can render these transactions without having to have the props being passed through to the different components. So it's just like a global context for this UI here. So this transaction that I'm sending right now, it'll say pending down here in the bottom right. I might be blocking that a little bit. And then you could see this transaction actually pop up here, right? So the transaction context is actually making it so we can add a transaction and all the other components can hear about it. And then we could go ahead and click out and actually see this transaction on ZKsync Aristopolia there. And there's our input data and we pass in no value in this case. So and it looks like we're still being paid for by the paymaster. I have that encoded in my environmental variable there. So these are all gas sponsored transactions. Okay, great. So yeah, we have all of that. What I want to do now is I want to actually mint some tokens. So I left a tab open here, which is this getting started with Hardhat. So what's really cool about getting started with Hardhat here, we've seen this in a previous video where once you get started with a Hardhat repository, it's going to give you some basic contracts right out of the gate. So we're going to make use of that. So what I'm going to do is I'm going to go ahead and grab this one, the ZKsync CLI create demo here, and I'll do my iTerm over here. And I'm going to go ahead and run this and call this like, yeah, maybe tokens deployment, something like that. And then this is going to ask me for a couple things. So I can pass in a private key if I have something that I want to go ahead and deploy there. So I'm going to use npm. This will set it up. And now we'll go ahead and pop in there. So cd tokens deployment. And we'll go ahead and open this up into code. Because what I want to do is I want to go ahead and deploy an ERC20 token. So let's go ahead and jump into this one. I'm going to zoom in a little bit here, make it easier for you to see. I'm not going to use any of this other stuff. So I'm not going to use NFT, not going to use paymasters for deploying this token. We still have paymasters inside of our UI, but not here. So I'm going to delete this NFT and then all the way down to the greeter here. So let me delete those. And then we have some deploy scripts, which we can make use of here. And specifically, I'm going to want to deploy this my ERC20 token. So they already have it set up. So this is a burnable token, which is kind of cool. So maybe we could actually make it so that we'll actually make a burn UI too. We'll mint the tokens and then we'll burn the tokens, right? That'll be kind of cool. So let's do that. So ERC20 burnable, you'll actually see there's this method called burn, where we can actually pass it in an amount that we want to burn. One thing that we'll want to do here is you can see that the initial supply is getting mined to or being sent to this deployer's address being minted. We want to go ahead and add maybe another function that is going to allow us to mint some more, right? So, well, how much do we want to mint here? We can go ahead and put that in here. And then there's this underscore mint function that we can go ahead and call and pass in a certain amount to whoever's calling this, right? So we're going to be calling this with our embedded account within the UI and saying we want to mint some more tokens from that. So we're just going to make it so anyone can just mint more tokens, burn more tokens with this, just so that we have something that's easily something that we can actually take action on within our application here. Okay, great. So once we have that, you're going to see that in the default Hardhat setup here using the ZKsync CLI, we can use ZKsync Sepolia testnet, and that's actually the default network. So if we run the deployment script, it's going to do this by default. And we already have a private key set up in our .env that's going to pay for the gas. And the last thing we need to know is how to run the deployment scripts. So you can see that there's this deploy script, but it's running the deploy script right here. What I want to do is I want to run the deploy script in ERC20 / deploy.ts. So I'm actually going to change this ever so slightly. So let's go ahead and pull this up. I'm going to do npx hardhat script ERC20 / deploy.ts. And then we'll go ahead and run that. And hopefully that'll go ahead and deploy. No. Okay, so one thing it won't do for you is you actually do have to compile. I'm used to that automatically compiling for me, so I forgot there. So we'll give it a sec. And then we'll go ahead and deploy this here. So starting deployment, there's my deployment cost, and we'll have ourselves a token momentarily. Awesome, there it is. Okay, so here's our token address. This should be out there on ZKsync era. It's verified, so hopefully we can go see it. That would be sweet. So if we go to our address, this is gonna bring us to the block explorer. And then if we put this address in here for the token, it should already be verified. Look at that, my ERC20 token. Awesome. So it's out there. So now we can actually start to interact with it on ZKsync Sepolia. So that's what I'm going to go ahead and do. Is we're going to change up this UI to mint some tokens, and then we'll also burn some tokens, right? We'll have a UI for both, mint and burn. Sweet. So let's go ahead and do that over here. So let me just pull, this one's over here. Okay, great. So what I'm going to do is first just make, if we're going to do mint and burn within our UI, I want to be able to access the contract address in multiple places. So a nice place to kind of put that is there's a config file here. Mostly what the config file is doing is it's setting up the Alchemy signer, and that's all part of the embedded accounts UI from the account kit. So again, if you want to see more documentation on that, you can actually find this account kit right here, and you can click on this. I might keep this open because we may find it helpful to reference some of these React hooks here. So I think I'm going to use maybe a couple of these. So these are always really helpful. I think you'll see that throughout this app, we already use quite a few. So use user is one of those where if you want to access the address like we have here, you could just use user, and then it's going to pass you back something that you can actually grab the address for your user that's signed in via the email there. So that's going to be one of the hooks that we can make use of. So I'm going to keep this open for now, and then what I'm going to do is go ahead and make it so that we can mint some tokens here in this transaction form rather than sending just a transaction like that. Okay, so in the config, this is setting up all the embedded account stuff here. You can find more about that within the documentation if you go to the quick start or Alchemy signer documentation there. What I'm going to do is I'm going to go ahead and export a new const. We're just going to call this the token address, and this will be hex, and then we'll just pass that in over here. There's our token address. Okay, great. So I'll go ahead and save that, and then what I'm going to do is come over to our transaction form. So within the transactions dashboard, this UI here, there's this transactions main, which is going to be the main, just going to be the top level component that we're actually rendering from our home route here. So there's the transactions main. So this is the top level one. We have this transactions provider here, which is going to be the context where we keep all the transactions, right? So every time that we run a new transaction from transaction form, we send a new transaction to the chain, it's going to add that to the transaction context so we can render it within our transactions UI down here. So you can kind of see within transactions context, there's a few things in here. Let's see, where's the easiest way? So here's the context type. There's going to be an array of transactions, which are just a hash and status. But if you wanted to do more, like you wanted to add more information here, maybe the name of the token or how many you minted, whatever, you could certainly add that in here. And then add transaction here is going to be when we have a transaction hash that we want to add here. And then it's going to go ahead and take a look at the status and keep us updated as to whether or not the transaction has succeeded or reverted. So you can actually see that that's built in here to get the transaction receipt to go ahead and update that status. So you may have noticed in the UI that when you go and send these transactions, at first it shows a little time icon. So there it is right there. And then it goes to check when it's successful. If it failed, it would show a different icon. So that's automatically being handled for us within that context there, which is super nice. Okay, great. So that is the context. And then we have this transaction main, and we have these three different components. We have the account details, which is going to render that user up here, right? I said we were going to use this use user hook. And within that use user hook, we can go ahead and grab the user and get their address and then be able to render it here. And so that's rendering this component up top here, where we can go out to the block explorer and see our address that's associated to our user by their email address. Now we want to mess around with this transactions form right here and be able to change this ever so slightly to be able to mint some tokens. And then we also want to be able to burn some tokens. Okay, so let's go back up to transactions main. Here's the transaction form right here. I'm going to call this now, let's call this mint tokens. Let's just call this mint tokens. Sure. That's also the name of the dashboard, but whatever. And then there's going to be this transaction form. So when I change this mint tokens here, just to show you, that's going to change this little thing right here. So this is going to be our mint tokens form. And then we're going to go into the transaction form, and we're going to change a few things in here. So right now the schema for the form, there's like a whole form that's being validated here, has a few different things. It has the target, the data, and the value, right? Which is these three inputs here, the data, and the value. We want to change these. So now we're going to make it so it's just going to be an amount that we're going to mint. So let's just make an amount that is going to be the is going to use this number formatter to make sure that this is actually a number that's being passed through by the user. So we have some form validation there. We won't need this hex stuff anymore because we're just passing in a number. So I think a lot of this can go away. Maybe even more. If we get rid of this the schema and we say this is going to be an amount for our interface, for our type there. And then what's going to happen inside of the transaction form is we're basically going to keep it the same. So it's using the transaction context so that when we go ahead and send a transaction, it's going to add the transaction. So that way in our UI, all of our components know about this transaction and can get that status update when the transaction's actually been completed on chain. So what we want to do, so the other thing here is this use transaction. Now this is actually something that I built in here into web3. Underneath components web3, you'll actually find this use transaction hook. Now the reason why I built this in here custom is because it's using some of the custom logic that we need to make this work on ZKsync with the Alchemy signer. Specifically, that's going to be some of like the native paymaster stuff in order to get this to work using a 712 transaction here. So we do need to do some special logic here to make this work. So that's all baked in here in this use transaction hook, along with a nice toast component. So you see that little toast that comes up in the bottom right corner if I'm not covering it too much on the video. So yeah, this use transaction is going to be something that's very useful for whenever we want to send a transaction. If we have a paymaster address in our .env, then it will already sponsor the transactions. Otherwise, we'll just send it. Cool. Just like we went over in the previous video. So that's our use transaction. So what we're going to do is we are going to do basically the same stuff. We have a form down below here, which has a bunch of form fields. It has a target, the data, and the value. We want to change this so we're just going to have one form field, and it's going to be an amount. So we're going to call this amount. And we're going to say amount, and way is kind of annoying to enter. So let's just do amount, and then we'll multiply it by 10 times 10 to the 18th. And then we will pass in a value there. So that should do the trick. And we'll just come back up here to our default values. We're going to make this amount here is going to be 0. And then we'll take in the amount from the form fields, and we'll do amount. Okay, so for send transaction now, this is going to be a little bit different, right? Send transaction, we still want to use this send transaction hook because this is going to do all the fancy paymaster stuff and all of the combining the Alchemy signer with the ZKsync type transactions. So we still want to use this hook. Now the difference is we are going to be targeting that smart contract address. So I believe I called it like token address here, like that. And then for the data, we're not going to be passing in any value here. For the data, we're actually going to encode function data. So we're going to target a function on our contract. I believe I called it mint more. So if we go back over to our token over here, I called it mint more, and then I passed it in a uint 256. That's all we need to know here. So that should do everything that we need to do. If we take a look at encode function data, a lot of the times you'll see like nice, not really in this case, comments to show you like how to use this. Because sometimes I just forget the parameters that we could pass in. It's like an ABI function name. All right, so let's do that. So the ABI is going to be, we could go grab the ABI, right? We have it as an artifact in our Hardhat repository, and it'd be nice maybe like if we could actually just automatically spit that out where we need it inside of the application. But just for now, to keep it simple, we know what the name of the function is going to be that we want to call. So we can go ahead and do function mint more, and this is going to take a uint 256, and it's going to be external, and yeah, that should probably do the trick for the parse ABI. We'll see if that's good enough. And then for the function name, we're going to pass in mint more. And then for the arguments, we're going to pass in how much we want to how much we actually want to mint, which is going to be the amount. And I think this is going to want me to do a big int here. And that should be about it, right? So the two data, it might be mad because it wants a value as well, so we'll just put in 0. Okay, so that was mad about that. We didn't import parse ABI for VM. So let's go ahead and grab that. And then, yeah, it's yelling at me for something else as well. Not assignable. It might just be not parsing the ABI correctly there. Okay, sweet. There we go. You got to be careful how you put that in. I guess no semicolon there. Okay, great. So that looks good to me. So now we should actually be able to mint some tokens. Yeah, I think that should work. So let's go ahead and set that up. What I want to do over here is just go ahead and put in, so for the amount, the default now should be 0, right? I don't know why that kept that address in there. So there's the 0 amount. So if we go ahead and send this, hopefully we'll mint some tokens. Let's go ahead and see that happen. Transaction pending, pop open the transaction. Cool. It looks like we minted some tokens. So 0. So that's not super fun. There's my how much, and I put in 0 over here. I did say that we are going to multiply it by 10 to the 18th, and I totally forgot to do that. So let's do that as well. So we're going to do big int times 10 to the 18th. So we'll make these all big ints. And so that way we can actually pass in the amount that we want as a user, the way we think about it. Like 10 tokens is 10 tokens to us, but to the machine, it's 10 times 10 to the 18th, right? So let's go ahead and do 150 tokens here. And hopefully in our second transaction, we will now see 150 tokens minted. Let's go ahead and click that open. And there it is, 150 tokens being minted. You could see it right there. There's my 150 DTN, which is the default token name. I guess that's what it stands for, DTN. Sweet. So 150 tokens minted. That looks pretty good. One thing that might be kind of nice is if in our account we actually showed the balance, right? Like how many tokens you have in this UI. We can do that, right? We have the information we need there. So let's go ahead and update that so that we can always see like an up-to-date balance whenever we're minting tokens. So if we go back here into our transactions main, and we take a look at the account details. This is going to be that component there that controls the address. We're going to want to get the balance here as well. So let's do something like this where we say, there's your address. Let's say your balance. And then we're just going to pass in a balance here. So for now, we'll just do 0. Let's not make this all... I won't make this a link, although that might be kind of cool, right, to link out to the Block Explorer. I'm just going to put 0 for now. And what we'll do is we'll have like a balance, set balance, use state hook, where we're going to pass in 0. Maybe we'll make this a string. I'll show you why in a second. And then we will pass in this balance over here. And... okay, so now if we want to get the balance, right, we're going to set it to 0 by default. Probably be better to show a loading to your users so that way, like when they first come in, it doesn't, but we'll just stick with 0 for now. So it'll say 0 and then populate the actual balance. We're going to do a use effect. And in the use effect, we're going to go get that balance, right? So how do we get that balance? Let's make an async function where we actually go and... get it. It's going to be an async iffy, so I can use await. And where do we actually get it from? So now we need something that can interface with a Ethereum node, ZKsync node, right? So that we can actually go get that balance there. So what we can use is one of the hooks that we get from AA Alchemy React, that's going to be from the AA SDK, from the account kit, is going to be this use bundler client. So what we can do is we can go ahead and say, let's do use bundler. So const client is equal to use bundler. Now this client right here is going to be a client that's configured in that config file up at the top. So it's going to have all of those settings there. So if we go back up to config, you're going to see all the settings here for how it actually sends through RPC requests and things like that. That's going to be the main thing, right? We're going to be sending that back to our API route, and then it's going to handle everything from there. So that's already set up for us to proxy that over to the RPC. So we have this client here. And what we're going to do with it is we're going to read a contract, which is going to be our token contract to get that balance. So let's do that. So we're going to say the balance is, maybe I'll call this something else, right? Not that one, but let's just, I'll just call it val is equal to await contract.read contract. Wait, what am I doing? Client.read contract. And now I think what will be helpful here, if we go in here to the read contract and take a look at the comments. And this is usually pretty helpful right here where we can actually grab this out and we'll bring these over and get rid of the little comment asterisks here. And now we have all the all the arguments that we need. And look at that, that's actually pretty close to what we want, right? We want the balance of, that's going to be the same as the ERC20 balance of pass in an address, get back a UN256. Perfect. That actually works really well. The two things that we do need to change is going to be this address right here. This is going to be the token address. We're going to ask for the balance from there. And then this is going to be the user address right here. So we'll pass in the address there. Now this is going to complain because it could be undefined. If it's undefined, then let's just not do anything. We'll just return in this case, and then we'll pass it in as a dependency. So if it changes, we should just reload. I think it's also going to ask that the client is passed in here as a dependency. So if that changes, I guess we'll reload too. And then we'll set the balance, right? So let's set the balance. It's going to be this. Okay, cool. Now, it's going to be this, pass in the val. Okay, sweet. So one thing that we might want to do here. Okay, why is it mad? Oh, it's a big int. Yeah, so the reason why I was saying we should turn this into a string is if we try to pass this in as a big int, I think we're going to run into an issue down here. So we'll just change this to string. And then we'll just treat it as a string from there. That'll be kind of nice. Okay, sweet. So great. So what we have set up now is we are able to go and read the balance, but this is only going to read the balance on page load, right? So if we go back over to our application here and we see, hopefully now if we refresh, we should see 150 balance if this is working. Okay, so it's showing it as 150 plus 10 times 10 to the 18th or times 10 to the 18th. So that's going to be all the way out there. We might want to read this as, let's do like a parse ether from VM, and then we'll pass in the val. And then what will this return? Will this return a string? Returns a big int as well. So we'll do a toString. This is going to be, wait, no. I want to do format ether. I'm thinking the wrong way. Format, remember, it's for the user, format for me. Great. So format is actually going to return a string. So that's actually, we don't have to do toString here. Format for us, format, and then parse ether for the machine. I always got to get those, always got to think through those. All right, great. So that's going to be our balance there. Hopefully now if we reload, it's going to say 150. Okay, cool. So if we want to make it so that when we actually mint some tokens, we see that update, we do have that transaction context, which is changing, right? And it's showing that in the UI. So I'm going to make use of that transaction context here and also have that trigger a change in the balance. So let's go ahead and do that. This may not be the most efficient way of doing it, but it's pretty quick right here, is we could say use transaction context. So this is going to give us access, use transaction context. So this is going to give us access to the transactions array, and the transactions array is going to change as we add new transactions and as we change the state of those transactions. So this is going to be kind of helpful in that regard. There may be better ways of doing this, but this isn't bad, right? Like every time we change the transactions, we could trigger this use effect to go ahead and go and fetch the balance. Now, maybe you would want to do something so only when a transaction changes from pending to successful, then it refetches the balance, right? You don't want to do the refetch on balance when it's still a pending transaction, whatever. So you could definitely optimize this, right? But this should at least trigger it. So anytime we have a transaction change, we're going to go check that balance. So hopefully now if we do something like 175 should go up to 380. So if I go ahead and click that and then wait for my transaction to append, there we go, 380. So now it's actually updating my balance as we mint these tokens. So let's go ahead and do one more thing, which is going to burn the tokens. Let's create another UI down here. And so we can see what that would look like. So if we go over to our transactions main, we have this mint tokens field set, and we're going to want to make a burn tokens field set. And from that, let's create a new form. We're going to call this form burn form. And we'll go ahead and rename it and then import it. So let's call it burn form. This is going to be pretty similar, right? So let's go ahead and just change that here, burn form. And then we'll come back over to our burn form. And this is going to be pretty similar. Actually, it's going to be almost exactly the same. The only difference is instead of mint more, we're going to be calling burn, right? Which is that function that was because we inherited from ERC20 burnable here. We have this function burn, which is going to take in a uint amount. So we can do the same thing over here where we say uint, and we'll just pass in that burn here. And we'll do the same thing. We'll multiply it by 10 times 10 to the 18th, and we'll go ahead and burn a certain amount here. So if we wanted to burn 300 tokens, let's go ahead and do that. Let's see what happens if we burn 300 tokens. Hopefully this will be 80 after that. All right, sweet. Looks like the burn's working. I'm curious what would happen if we tried 90. So what would happen? This is going to test what I know about my use transaction hook that's in there. I mean, what should happen is when you go to estimate the gas, it's going to simulate this and it's going to fail. I just don't know what the error handling is in here. So let's see what happens. Oh, there it is. Sweet. So this actually came up as a Next.js error, and it says ERC20 burn amount exceeds balance, which is appropriate, right? We don't have enough tokens to burn that. So the 90 is not going to work. We could dismiss that error and then maybe go ahead and put in 80 here, and then hopefully see that we burn our balance down to 0. New transaction came in, we burned our balance. Here's the transaction for the burning, right? So if we wanted to see that, there's the burn amount. We're burning some tokens. Basically just sending it to the address 0, and we could give ourselves some tokens again, 175, why not? See that balance go back up. And there it is. Great. And we have ourselves a mint burn token UI, right? So you could pretty much imagine whatever kind of smart contract UI you want to create here, you could do it. Maybe show the transactions here. Maybe you want to show something a little bit more user-friendly here, right? Like something like instead of showing the transaction hash, I mean, this is nice for me, like here as a developer, like to be able to click into these and see these transactions. But for a user, maybe you want to show something else, right? Like something like we minted 175 tokens here, or we burned 80 tokens here, that sort of thing. So that's definitely something I'll leave to you as a challenge if you want to try this out. Follow along in the video, start from the AA starter and try it out. I'll even create a fork branch of the repo if you want to just start from where we are here, and I'll leave that down below. It'll be like a mint token forked branch. And definitely give it a try in making your own smart contract UI. Give this a shot, see what you can build, and look forward to seeing what everyone produces from this.